class, this is Mrs. Vandewalle. What's new? C over lambda. Hey, you're right. And so what we're going to do today is go on and no longer talk about the idea of frequency and wavelength, but talk about energy and where the electrons are and electron configuration. So that's what today's lesson is all about. I would really like it if you could get out your packet that you got yesterday, and if you weren't here, the sub will give you the packets. I left some on my desk. And so I would like to have three things out on your desk right now. A periodic table, and you can use the one that was in your notes from yesterday, like this one. And if you could have the sheet that I called the ladder sheet yesterday, this is the front page of that packet, and then have your sideways packet. It looks like a grid that said element, valence electrons across the top. So if you can get those out, that would be great. Okay, so you have your periodic table, you have the ladder sheet, and you have your notes. So let's begin. Yesterday, if you turn to your notes, you also found where we talked about these orbitals, that these are the solutions to Schrodinger's equations. We found we had one s orbital, we have three p orbitals, and we have 5 d orbitals. There's also an f orbital that would have 7 different shapes associated with it as well. And these are the probable locations of where the electrons can be found. And what we discovered is that your periodic table is set up perfectly in conjunction to Schrodinger's equations. So if you would, if you haven't done this already, literally cross out helium and put helium over here. And then what we discovered is that because S has one orbital and 2 electrons can go into an orbital, 1 times 2 is 2, and these 2 tall columns up here is what's called the S block. Well, there were 3 p orbitals, and 3 times 2, each orbital can hold 2 electrons, is 6. And these 6 tall columns on the right-hand side is the p orbital, or the p block. And there were 5 d orbitals, and if each orbital can hold 2 electrons, 5 times 2 is 10. And these 10 columns in the middle is what's called the d block. Well, there's the F that has those 7 orbitals, and the only remaining spot on the periodic table we haven't identified would just happen to be this area down here. Now 7 times 2, 2 electrons per orbital is 14. And if you count across, hey, there's 14 elements in each row. So this is what's called the F block. In a first year chemistry class, we probably really won't get into the F blocks at all, so we probably won't worry about them, but that's where the Fs are going to be located. So what do we do now? Well, the result of the Bohr electron was talking about those different energy levels. And if you remember on an earlier page in your notes, we found where n went 1, 2, 3, 4, 5, 6, 7. Well, here are those same energy levels. So right here, this is what really Bohr came up with, is these energy levels. What Schrodinger did is that he added to the Bohr model and just said they aren't just rings around the nucleus, but they are sub-levels. These are different locations, just a circular path around the nucleus. So Schrodinger subdivided these levels into S, P, D, and F. Now note, n equals 1, the lowest level, only has S subshells, only has that sphere. But n equals 2, notice we have 1, 2 different sublevels for the second energy. And then when n equals 3, well, what do you know? There are 3 sublevels, 1, 2, 3. For n equals 4, guess what? There are 4 sublevels, S, P, D, and F. And so these are the same idea of energy rings, or the energy levels that Bohr came up with, but Schrodinger made sublevels from that idea. And that's what we talked about yesterday. So let's just go ahead and put this all together. You have that sideways sheet. Mine isn't quite so sideways, but you have this sheet, and it has the element on top, and it has electrons, electron configuration, orbital rotation, and Lewis dot. All right, at the top of your sheet there, I know that the column to the right of the element column says valence electrons. Can you just cross that out and just write the total number of electrons the way I have it on here? We'll talk about valence electrons another time. So today, let's just talk about the total number of electrons. And if you remember from last chapter, the total number of electrons is equal to the atomic number, or the number of protons for a neutral atom. So we're going to go with that. That's why you need a periodic table today. So let's look at the very first element, hydrogen. And the atomic number of hydrogen is 1, so there are 1 electrons, or just one, there is 1 electron. And now to do the electron configuration, that is a shorthand version of how to describe where these electrons are. So we need to represent really 3 things: the energy level, the sublevel, and how many electrons. So if you look on your periodic table, right here, we have the S, P, D, and F, but we need to identify the different energy levels. So I'll use blue to do that. So this energy level is 1, 2, 3, 4, 5, 6, 7. And so those are the different energy levels. And what we said is that the lower the energy level, the closer it is to the nucleus. So what does that tell me? That hydrogen and helium are in the first energy level, and those electrons are closest to the nucleus. And then lithium, beryllium, all the way to neon are in the second energy level, and that's the next layer closest to the nucleus, and so on. So when you get way down to the bottom with francium and radium, those electrons are pretty far away from that nucleus because they're in the 7th energy level. So to go back to the electron configuration, we are going to talk about which energy level hydrogen is. It's in the first energy level. Now, what subshell is it in? Notice it's in the S shell right here. So it's in the first energy level. It's in the S sublevel. So I need to identify that as well. And then how many electrons does it have in that particular sublevel? So if I look right here, it's only 1 electron. It only has 1 electron, but there's 1 in that 1s subshell. So I'll put a little 1 up here. So let me kind of show you what everything means. The first number out in front is the energy level. It's either going to be 1, 2, 3, 4, 5, 6, or 7. The S is the sublevel that Schrodinger came up with. And then the number on top is how many electrons in that particular sublevel. Now we have something called the orbital notation. This is more of a visual picture version of the electron configuration. And if you recall yesterday that I had just 1 S shell right here. So because, I'm sorry, 1 orbital right there. So with 1 orbital, I only had 1 of those models of that sphere there. And because there's just 1, when I do the orbital notation, I just put 1 dash. So however many shapes there are is how many lines, how many dashes you're going to draw. So S has 1 dash. When we get to a P, it'll have 3 dashes. If we get to a D, it'll have 5 dashes. So here S, 1 dash. And then you have to label the energy and the sublevel underneath it. Make sure you do that. And finally, the arrow on top that says how many electrons, or the number on top that says how many electrons, that's your arrow you put in the orbital notation. And yesterday we talked about why did we have the arrow up, arrow down, and that has to do with the spin of electrons. If you recall, if I have 2 stationary electrons, they're both negatively charged. They will repel each other. But if you get those electrons spinning, they will form a magnetic field, and if you can have one spinning in one direction, and if you need to put another one in, it spins in the opposite direction, they can both coexist. It's like forming a north pole and a south pole of a magnet, and they'll coexist in that same spot. We're going to hold off on the Lewis diagram for now. We'll talk about that later. So that's all we need. We need number of electrons, electron configuration, orbital notation for today. All right, let's look at helium next. So helium was found on the periodic table. Helium is the one that you redrew on the left-hand side, and there's helium. So where is helium located? Helium is still found in that first shell. It's still found in the S subshell. But now how many electrons does helium have? Well, how many protons does helium have? It has 2. So if it has 2 protons, it has 2 electrons, and they're both in the S shell. So let's see how we're going to write this. So helium has 2 electrons. It's still found in the first energy shell, in the S subshell, and there are 2 electrons. So how would I do the orbital rotation? I draw 1 dash for the S subshell. It's in the first energy, so I write 1s, and there are 2 electrons. So like I talked about before about the spinning, I put 1 up and 1 down, and therefore they can both coexist in a close proximity without repelling each other. Now let's look at lithium. Well, where's lithium on the periodic table? Lithium's right here, and something's changed here. It's no longer in the first subshell. It's in the second subshell. And if you look at this energy sheet that you have right here, that if you look at when you filled up n equals 1, it is filled. You have 2 electrons there. Where do you go next? Which is the next highest energy level? It is the 2s. So your periodic table is really reinforcing this idea of increasing energy levels. So let's go back to the periodic table. So there's lithium. It is in the 2s subshell. And how many electrons are in that 2s? It's only 1. It's the first one in the s shell. But when you do the electron configuration for now, you need to place all 3 electrons of lithium. So where are the first 2 electrons of lithium? They're right here. 1s, 2s. Excuse me, 1s1, 1s2. I said that wrong. And then the third one is in the 2s1, where lithium is, right here. So let me show you how this goes is put together. So here I have lithium with 3 electrons. The first 2 electrons are in the 1s2 shell. You filled the 1s2, so now we need to go to the next shell, the 2s shell, and there's only 1 electron there. Well, what do you notice? Look at those top numbers. What's 2 plus 1? I think it's equal to 3. So that is another way to figure out if you did it right. Those numbers that you write on top should always add up to the total number of electrons. All right, how do we do the orbital notation? Here's your 1s. This is where your first 2 electrons are. And then here's your 2s. And how many electrons did we put in the 2s? Just 1. Okay, let's look at beryllium. Beryllium is found right here at number 4. I'll erase this because it's getting kind of crowded up there. So I'll put helium back in though. So here is beryllium. It has atomic number 4. There's 4 electrons. So if you notice, where is the electrons? It's in the 1s2. And then the third and the fourth one are in the 2s2. So let's go ahead and write that down. So beryllium has 4 electrons. The first 2 electrons are in the 1s2. And then the next 2 electrons are in the 2s2. Orbital notation, I write 1 dash because it's an s. It had only 1 sphere. And then you have 2s, up and down. So there are my 4 electrons. Now, what does this mean? I filled the s shell, but where do I go next? Well, if you look at the chart over here, after the 2s electron is filled, or the 2s subshell is filled, where do I go next? I go to 2p. Well, look at the periodic table. Once I'm done with 2s, where do I go? I go across where boron is, which is now in the 2p shell. So let's see how this works. And then what you'll have to do is the orbital notation.